In this video, we'll discuss change in position. We'll do a sample problem illustrating the PGUESSUS method. So change in position, we will be using this formula, delta y equals y minus y naught. Delta y is the change in position. That's what it means. Y naught is the initial position, or the position at time 0, or the beginning time. And y is the instantaneous position, the position at any moment in time. And that could be the end, but it's at the position at any instant in time. So let's look at our first example, our level 1 example. We have Nick, who's 15 meters in front of a car. He rides his skateboard until he's 39 meters in front of the car. What is his change in position? So using our PGUESSUS method, and as we're reading, we probably should highlight our important information. So we have 15 meters in front of the car, and in these 39 meters in front of the car, and then we're looking for the change in position. So we can actually highlight some of this information or label this information as we're doing it. So we've got 15 meters in front of the car. That looks like that's the initial position, so we might label that y0. And then we see later he is at 39 meters in front of the car, so that's y, and we are looking for his change in position, delta y. So just as we're reading, we can highlight and identify, label the information. And so next thing we're going to do is create a labeled picture. Well, we know that all bodies in the universe are situated in three-dimensional space, and we have the x dimension and the z dimension and the y dimension. And the y dimension goes off in that direction. And if we were to look at that, we see that we have positive y values and negative y values, and that ultimately this is just a number line. And all the motion we will examine is in one dimension on that number line. So next we will draw a number line. Like so. And we'll make the right positive and the left negative. And we need to have an origin or a 0 point. And we can see that all of the information we're given is relative to the front of the car. So we'll make that 0, and we'll call that the front of the car. And we are told that he is 15 meters in front of the car. Now I have to connect front and back with positive and negative. So I am just going to make front positive and back, or rear of the car, negative. And it's not wrong to do it the other way, but that's just the way I'm going to choose to do it. And so we have 15 meters in front of the car, so we'll say that's 15. And that we said is his y naught. And then later he's 39 meters in front of the car, so he's now here at 39, and that is y equals 39. And to help us visualize the motion, we can draw an arrow indicating he started from here and moved to here. So we have our labeled picture. We can identify the givens. We've already done that in one way, and we can do it more formally by officially saying that y naught is 15 meters and y is 39 meters. We are looking for the change in position, and that would be in meters as well. So we've identified the givens, and we've also identified the unknown. Now next we are going to identify the relevant equation or formula, and that is this one. So we will write that down. Delta y equals y minus y naught. And then we will solve for the unknown. Well, the unknown is delta y. This equation already is solved for the unknown, so it's delta y equals. So delta y equals. And then we are going to substitute values. Well, the y is 39, and the y naught is 15 meters. So we've substituted. We're going to calculate that answer, and let's see, delta y is then 24. So we've calculated it, and there's no rounding involved. So we've done our S, and now we're going to put our units, which is meters. And now we're going to express it with the proper number of significant digits. Well, our first position went to the ones place, and the second position went to the ones place. So our answer is going to be to the one place. Whenever we're subtracting things, it's going to be just the rightmost digit of the number, usually. And then we ask ourselves, can we express this number in scientific notation? And the answer to that question is yes, because all numbers in scientific notation, if we have the number 1 and we have the number 10, if it's inside this range, if it's inside this zone of 1 to 10, it's fine. If it's outside that zone, then we convert it to scientific notation, and we see that it's 24 meters. So we are going to convert it to scientific notation. Delta y then is 2.4 times 10 to the 1 meters. And how we know it was 10 to the 1 is we move the decimal place from where it was, from this location, 1 place over. And if you look at that number that we're left with, if we take 2.4 and multiply it by 10, that gives us 24. That's how we know that's the correct answer that we end up with. So our final answer, with the correct significant digits, the scientific notation, and we don't really need to add a SI prefix here because we're not up to the kilo level yet. We'll leave it just as 2.4 times 10 to the 1 meters. And these are the two final answers. Now, we ask why. Why do we do this? Well, sometimes we always convert it to scientific notation. But for our purposes here, right now, we are just practicing. But as we do more calculations, we're going to be needing to put it into metric prefixes. And so by putting it in scientific notation, it sets us up for easily converting it into scientific notation.